This lesson is for FST 4.8 on translations of trig functions. When we first did translations, that was back in lesson 3.2, so I took the information from that lesson and applied it here. So it's just a quick review of translating. When you do a translation rule, you use capital T for translation. The preimage is listed next to the capital T, and then with a colon or an equal sign, it tells you how you're going to translate or slide the graph. The number that's being added or subtracted to the x will tell you which way it's going to shift or slide horizontally. A positive number will move to the right, a negative number will move to the left. For the y value, whatever's being added or subtracted will tell you which way it's going to shift or slide vertically. Again, positive being up and down being negative. When you apply the rule to coordinates and graphs, you apply the rule directly as is. When you apply it to an equation, however, you do the opposite or the inverse of the rule. So if we apply the original rule that we had here and we apply it to the sine or the cosine, it's going to look either like this, or if we solve for y, it's going to look like that. Keep in mind, and this won't happen or be anything that students need to worry about today, but in the future, it's important for students to keep in mind that the coefficient on the x value must be a 1. When we get to lesson 4.9, we will have to do some factoring out of whatever that number is, and that process begins in this lesson here. So I don't think there's any that students will come across, but just keep that in mind that the coefficient next to x has to be a 1. So let's go ahead and try some practice questions here just to get moving. So we've got this equation of y equals sine x plus pi over 2 minus 3. So this is our equation, and we're trying to come up with what the rule would be. So the translation rule, first of all, I know it's translation because I'm doing addition and subtraction. It's important for students to pay attention to whether or not it's translation or, like we did in the previous lesson, a scale change, because it's going to affect what the graph is going to look like if you're doing one versus the other. So this is a translation. In the rule here, the x is being added to pi over 2. So in my rule, I want to say that the x is subtracting pi over 2. Keep in mind that that's the same as 90 degrees. So let's just talk about what's going to be happening to this graph in general. It's going to be moving left 90 degrees, or pi over 2. The other number that's in the equation is a minus 3. If I brought that minus 3 back over to where the y would be, it would be y plus 3 in the equation. So when I apply that now to the rule, or when I write the rule from this equation, it's got to be the opposite of what I see. So it says x plus 3 now in the equation, so that means in the rule it's got to be y minus 3. So if we think about what that's going to do to the graph, it's going to shift it down 3. So now let's go ahead and do a sketch of this graph. Keep in mind that when you're doing these, I would highly recommend doing them in pencil and giving yourself lots of room to do almost like a rough draft and then a final version. So I'm actually going to move this over so I have a little bit more room just in case. So just a quick recall of what the original sine graph would look like. Trying to use your grid lines here to help you stay organized. The normal sine graph does that. So I want to utilize the compass point spots here where the grid lines cross to help me maneuver according to this information. So everything's going to move back 90 or to the left 90. So that means the top of this mountain is now going to be on the y-axis. So everything now shifts over 1. So now the light blue graph has been shifted to the left, and then all of these points now need to shift down. So the top of that mountain now is going to go down 1, 2, 3. So that's the top of a mountain, and then it's going to go down and then back up. So now let's go ahead and draw the final result. If I had my graph, the new graph is going to be top of the mountain is now at 0, -2. And so then I would label my x and my y axes, and I would just put arrows on the ends to indicate that it does continue past what I've drawn. So this was just my rough draft, but the final graph is just the green graph there. Let's try another question for number 2 here. In the equation, the x is being added to 3 pi over 2. Again, that would be 270 in degrees. So if I write the rule for this, this is a translation rule. I know that in the translation rule, I would do the opposite of what I see here. So that's going to be x minus 3 pi over 2. So what that means is I'm moving to the left, because it's a negative number in the rule, 3 pi over 2, which is the same as 270 degrees. And then the negative 1 here, if I brought it back over to the y side, it would be a y plus 1. So I know that in the rule, it's going to be y minus 1. Because the rule and the equation are always opposite. So that's going to mean that it's going to move down 1. So now let's go ahead and make a quick sketch of that, and then we'll do our final draft. So if I do my regular cosine graph, it starts up at 1, goes down, almost looks like it makes a V shape, but remember the curvature of it makes it look more like a wave. So there's my original. So the new one is going to shift to the left 270. So there's a couple different ways you can deal with that. For me, I like to look at where the regular 270 is. So this spot right here is going to move back so that it's going to turn up or show up on the y-axis. So this point is going to just shift back. So if I just kind of mimic that, this point is now here. Normally that point goes up from there, and it goes back down here and then back up. So this now represents the horizontal shift, and now everything needs to move down 1. So if I take that point on the y-axis, it should shift down 1, and then everything else is going to move down 1 as well. So here's my graph here, and then I can just kind of sketch the rest. So this one's going to move down 1, this one's going to move down 1. So now I can mimic that graph on my final result over here. And let's actually do it so that the axes are the same. It makes it easier to redraw. So my y-intercept is at 0, -1. And so I'm just utilizing what I know about the shape of the cosine to help me draw the rest. It's also important here, and I didn't do this on the last graph and I should have, to put in some labels here. So I need to do a 1 and a -1, and the fact that this is at 90, 180, and so on. So make sure you include those pieces of information on your graph as well. One thing to keep in mind is that since these coordinates or these equations were in radians, it's probably better for us to label in radians as well. So make sure that you're consistent with whatever you're seeing in the original problem. So we'd want to say pi over 2 there, pi, and so on. If I had more room here and more space, I would probably label a little bit more than what I have, but for now I'd say just for a sketch for the homework that that's perfectly fine. Another thing to keep in mind here is that this should stop there. I made it a little bit too high on that particular graph. And then also just make sure you label x and y. So there's a graph of cosine of x plus 3 pi over 2 minus 1 is the purple graph there. We're going to do one final one, including a tangent. Let's write the rule first, and then we'll go ahead and make a quick sketch. The tangents are a little bit harder to translate just because they don't have a regular wave shape that we can manipulate, so there is a little bit more guesswork involved with the tan. Let's write the rule first. Again, this is a translation rule. In the equation, the x is being subtracted by pi over 3, so in the rule we're going to say x plus pi over 3. Quick reminder for students of what that is. That's the same as saying 60 degrees. So this graph is going to shift to the right 60 degrees. Now keep in mind for the tan, because there are asymptotes, that's going to move the asymptote 60 degrees as well. The y value is y minus 2 in the equation, so in the rule it's going to be y plus 2. So that means it's going to shift 2 up. So let's just review what the tangent graph looks like just kind of in general. A quick reminder that the tangent graph kind of does that. It looks kind of like a cubic function. Where it changes from one arc to the other is right at that x-axis mark. It does have asymptotes currently at 90 and negative 90. Or if we wanted to be consistent here and do it in radians, we'd say pi over 2 and negative pi over 2. So now let's talk about it shifting to the right 60. So that means both the graph itself and the asymptotes are going to shift 60 to the right, which means we're simply going to add 60 to both of these. Or we'd be adding pi over 3. But that's dealing with fractions, and so let's figure it out with degrees first, and then we'll translate it back later if we need to. So if we add 60 onto 90, then that one's going to turn into a 150. And if we add 60 onto negative 90, that's going to turn into negative 30. And then in terms of the two up, we just know that this point here where it kind of changes its arc, that's going to move up 2. So if I just do kind of a quick sketch, if I just move it up 2, it's just going to move up like that, but now it's going to shift over as well. So let's do a redraw of the x and the y axes. If you think about the original asymptote was back negative 90, we're going to go a third of the way closer. And normally the 90 would have been here, so we're going to shift over to here. And instead of just drawing a regular tan graph in between those, we want to make sure that that change in its arc happens up here at 2, kind of in the center between these two. So if I label this as a 1 and this is a 2, I want kind of that to be the spot where it changes from one arc to the other. So my graph is going to look kind of like that. And then I would just label in radians, but for now I'll let you leave it at 150 and negative 30 for those asymptotes. And so you can see that the graph from what it was originally has shifted over and shifted up.